All right, getting started for a 3D game. You can jump in and be able to create Unity's terrain, tree editor, render grass, particle systems, wind zones. You can also import Pro Builder to build low poly assets and rapid prototype your game. Whew, whoa, okay, that's a lot. Let's first back up with the basics and get some solid tips. So we're gonna open up Unity Hub. Now there are a couple things we need to start with. First thing, our project name. We're gonna just name this 3D game, and we wanna save this in a solid location, making sure you know where your game is saved at. And then we need to pick a template. There are 3 types of templates, essentially, and they all have to do typically with render pipelines. So which do you choose to start with? What are they? The 3 are going to be the standard or built-in render pipeline. Unity calls it the built-in pipeline. We also have the URP, known as the Universal Render Pipeline. And then we have the HDRP. If we scroll down, we have HDRP. Now, the built-in pipeline, pretty straightforward. Universal is going to be optimized for best-in-class graphics for multiple platforms. Typically very common to use on mobile games for sure. So if you're making a mobile game, you're gonna use URP because it's automatically optimized for that. Then the HD is gonna be high definition for ultra realistic, high fidelity, right? High-end graphics. So knowing once you've progressed and you know which kind of game you're gonna make, you could pick one of those. For starting out, we're just going to use the built-in render pipeline. And each of these render pipelines has recommended settings and packages, and you can change it at any time. So this is really just a starting point. So we're gonna go to core. We're just gonna select the 3D core, and Unity Hub is gonna change this. It used to just say 3D. Unity then changed it to 3D core. They'll probably change it again, but it's just gonna be the 3D basic built-in render pipeline. And I'm just gonna have it create this project on my desktop, where we'll go ahead and click Create Project and get started. All right, once that opens, we get our interface for Unity. We have our main menu across the top. We got this kind of mini toolbar here. And on the right-hand side, we have our layout, which may say default. And here we can change that. We're gonna stick with the default layout to just kind of be standard. And with that, we kind of get these 3 top sections that we're gonna talk about. We have the hierarchy, then we have the scene view, the game view, and the inspector. These 3 or 4 windows are very similar and connected together in some ways, but they also have some differences. The hierarchy, the main thing here is that this is a list of game objects in which we can parent and group things together. We have the scene view, right, which is our visualization, where we can place out our level and visually see where everything's at in the level. And then we have our game tab, or our game view. This is going to be specifically what the player sees. It's based on the camera. So this is going to be whatever the active camera is. The inspector, whatever object we have selected, we will get information, right? You're inspecting something about that. So if we select the main camera, we're gonna specifically get components and materials related to whatever object we have here. So with our camera, we have the transform camera, audio listener components on here, which have specific settings for each one of those. So we're gonna go to our hierarchy window, and there are 2 ways we can create additional objects, just some basic geometry. We can either do the plus, which is kind of helpful sometimes if you haven't grouped things together and you have a big list here, you can click the plus symbol. And we can also right click and then go to 3D objects. Now you'll notice there's no 2D because we started out with a 3D game. It only has the 3D package installed with all the 3D elements. And if we wanted to have 2D stuff in a 3D game, then all we need to do is import the 2D package so that we can do 2D and 3D together. And the first thing that we'll create is a plane. Name this ground. We could hit enter to apply that. You could also go over to the inspector and here change the name as well. Just make sure that you hit enter and that'll update the name. Let's right click and create an empty. And I'm actually going to call this an empty for right now. So every single one of these is a game object, but what makes them something specific all depends on the components. So a camera has a camera component, right? The directional light, the main thing we have, the light component. You can see also every single game object, even this empty, has a transform. So I'm going to switch from my game view to my scene view, and actually we can rearrange these. If you remember, we can grab this tab and drag it to the right hand side, and you'll kind of feel it snap. And you can rearrange these layouts any way you want. If you accidentally remove one or make it disappear, you can simply go up to the layout tab and click default. And if you happen to mess up all of them or the ones that you really want to use, you can reset all layouts as well. So we've got our ground plane, we've got our empty, and we'll go ahead and create a couple more objects here. And if you ever need to deselect, you can just click in the empty space and that'll deselect. I'm gonna go ahead and right click again, 3D object, we'll do a sphere and we'll call this player. And we're going to right click, 3D object, let's also do a cube. We're gonna call this box. And now we've got some basic geometry, which leads us to moving around in 3D space and kind of utilizing the scene view. So we have this quick toolbar here. In different versions of Unity, they kind of have the toolbar moved around the layout, but we have some standard shortcut keys, and that is W, E, and R. So W, move, E for rotate, our rotate gizmo, and R for scale. I like to call them Vuv, Etate, and Rail. W, E, and R. You get used to the gizmos where you can kind of memorize them. Now, before we move anything, we also want to kind of orient ourselves so you kind of know where I'm moving things based on where you're moving things. So let's go over movement. So the first thing is if you press your middle mouse button down and hold it, you'll get the hand tool, and we can track left and right or up and down. The second movement is going to be orbiting around in the view space or the scene space. And that is going to be Alt, hold down Alt and the left mouse button. And when you hold down Alt and the left mouse button, you'll get the eyeball icon. So this is, we can orbit around our scene. The next thing is a quick way to zoom. There are kind of two ways. One is, if I want to just zoom into the center of my screen here, if you hold down Alt and the right mouse button, you'll get the zoom tool. And then all I need to do is move my mouse left and right, and it will zoom in or out. But it does this to the center of your scene view, wherever the current center is of the view. I don't use this very often, but it can be helpful, is if you just hold down the right mouse button, you'll get this eyeball Tetris symbol. So this one actually rotates your view, or from your view. So test those out. Now, one of the things that happens is you might either zoom in too much, or you might move so far out that you can't even figure out where you're at in space. And you're like, I don't even know where all my stuff is. There are two shortcuts to be able to get back to being able to visualize our objects. The first one is I could select an object in the hierarchy and put my mouse in the scene view. Very important. Your mouse has to be in the scene view, and you can press F to frame it. And F will frame your object, and it brings it to the focal point of the center of your screen. So F for frame. The other way, instead of trying to go to the scene view and press F, I can actually just double click the ground plane, and double clicking in the hierarchy will zoom or frame whatever you're double clicking on. So that's really useful. Now, you may or may not have a grid. I think by default, usually the grid is on, but sometimes the grid is off, and you just get this gray space. But the grid orientation here, we can turn that on. It's really useful. You can see that's lined up with our ground. Now, depending on what we're doing with our game in the future, you may need to change the grid orientation, in which we can change the grid plane, say to that. We've got the X and the Z, but we're gonna leave that just now at the Y, but that is grid orientation. And then we have snapping. So the arrow will give us the snap settings, and then we have to actually click this magnet icon to turn it on. but you won't be able to turn it on if you're in local mode, okay? Local mode. You have to be in global mode, and then we can turn in snapping. So what that does is if we press W, I can snap my player, or in this case, let's move our box. But then you might ask, well, which direction am I moving the box? Well, let's first take our box that we just moved. Let's reset it so we can go to the transform, go to the 3 dots and reset it so it's back to the center. So what we want to do, if you want to have the right orientation for starting, is we remember the X and the Y. So the X is the red arrow going left and right, so we can make sure that's left and right. The arrow will by default be facing to the right. The Y is going to be up and down, and the blue arrow is our Z, which is actually facing forward. So if we were set to say transform dot forward, that would be facing that way. That's that transform. So that's the direction we actually want to move our box, is forward with snapping on. So we can snap it until it's 3 in the Z. So then you know that it's going in the right direction. So that you can see a couple things from here. The grid is one unit, one unity unit. So each box is a 1 by 1. And also our player is a 1 by 1. We want to leave our player at the origin, but we want our player to be sitting on top of the ground. So if half of our player is underneath the ground, our player is 1, scale of 1, so that's how tall it is 1. We only need half of it to move up. So what we can do is the Y is the up, and then we'll just put that by a half. Bam. Moves it directly up. When you start building a level, the snapping is going to be really, really useful to be able to snap things around and utilize the grid. Now I go over orientation real quick. If I were to rotate this box, so I'm going to hit E for etate and rotate this cube here, and I press W. So the global gizmo allows me to just move it standard, up and down, left and right, back and forth, right? But let's say I don't want this to be snapped at all. I can turn off snapping or leave it on, but I can change my mode from global to local, and then you notice the gizmo changes to the local rotation. So I can move it at that angle. That can be really useful. So I can move it along that axis the way it's facing. So at times we'll want to use that global or local. Really useful. Now for a couple helpful tricks. And that is, I want to leave my box at this position, but I want to get rid of the rotation. So what we can do is on the transform component, go to the 3 dots, and there is a reset rotation. On the older versions, you would just go to reset rotation. On the newer versions, you actually have to go to reset property and then rotation. So all we're going to reset is the rotation. So the cube or the box stays in the same position, but we reset the rotation only. And we'll leave that there. Let's go ahead and create another 3D object. We're going to do a cube again, but this one we're going to call wall. And we can move this one out. And I'm going to scale this on the Z to 5. And then we want it to be taller. So we'll maybe on the Y, we'll make it 2. Which means if we want it to be sitting on the ground, half of it is underneath the ground. So if it's 2 on the Y, we just need to do half, which would be 1. And now the wall is sitting on our ground. And then we can still snap this with our move gizmo and move it over a little bit more. So this wall is a 1 by 2 by 5. Our cube is uniformly scaled because it's exactly 1 by 1 by 1. We could make this a 0.5 by 0.5 by 0.5. And it is still a uniformly scaled cube. So a couple quick notes as well. Every game object has a transform, and the default value, if we look at when we created these, the default value for scale is 1. Even if we go to our empty, the default scale value is 1. Now position and rotation are 0, yeah, but scale is going to be 1. Let's go ahead and add some color to our scene so we can right click in our project window. This is where we'll have our imported assets as well as where we'll group things that are maybe not in the game yet. So if we right click, go to create, and we're going to do a material. Not to be confused with a physics material, but just a regular material. And for this, we'll call this one ground material. And to change the color of this ground material, we just come over here and we have a bunch of settings in the inspector. First thing that we want to go over is albedo. The albedo is basically the color map. Just what is the color? Now, we're not actually using a texture or a map, but just this color box. So we can click that and change it. Maybe we'll go for this brownish color here. We've created it in our project, but it is not in the game. Now, the easiest way to get this in the game is really simple. We can just drag this onto the ground plane, drag and drop, and boom, it's on there. If we select the ground, you can see now it says ground material, and it's got those basic settings here as well for that material. Now, if we go to like our player and our box, you'll see they have this default material. The default material is always going to be white, and we'll just leave it like that. For now, we're going to go ahead and create a couple other materials. So we'll, in the project window, right-click, create material, and we'll create one for the wall. Right-click, create material, and we'll create one for the player. Then I'll select the wall material. Maybe we'll change this to a grayish color. And our player, make our player a nice blue. Maybe our ground, I'll make like a darker ground. We can drag these onto our objects here. Now, if we want to change certain things about the color, we got to go to the material, and these settings are going to help us control certain aspects of that. So the albedo is just the color. Metallic and smoothness, we can actually control if it is like really shiny plastic, or if it's a really shiny metal, or if we're trying to get like that mirror quality. So if we turn up the metallicness, we'll get this really, really, really shiny looking material. And the smoothness is going to be how tight of a shiny area. So maybe this would just be shiny plastic, or maybe we'll increase that up and we'll create something like paint on a car. Some of the really cool ones, I often use the normal map and the height map for creating the illusion with texture, like 3D modeled details that aren't actually 3D modeled, just with lighting. Occlusion is really nice when you want to have certain areas that you don't want to be lit up at all. And then emission, very common if we wanted something to glow. When I have some glowing lights or some glowing sci-fi panels, right? That'll be really useful for that. In most cases, I've found that works best if we're using URP. It's already optimized with that, and you can set that up really quickly. And we'll go over more of that later. We'll just keep it basic for right now. So we'll make our player shiny and our ground not so shiny because it's the ground. So we get some materials there. Now we're just doing this manually, but when we get to, I should say, importing 3D assets, you might have other files from other programs, like an object file or an FBX, in which it already has materials and textures set up that we can import in and use. And FBX can also have even animation information from other programs as well. But we'll just keep it basic for now. So now that we've got kind of our objects here, we'll kind of get our scene set up. You'll notice that the player already has a sphere collider, not a 2D collider. It's just a regular collider, which any of the colliders for 3D, they don't say 3D unless if Unity changes that in the future, but it just by default will just say a collider type. So this one is a sphere, and we can have more than one collider on there, but we're just gonna have one. We've got the wall, which has a box collider on it, and our ground has a mesh collider. Now this ground plane, typically we're going to have some models. We're going to import some stuff because this would not work for maybe the roof of our building or a wall, because if you look at it, it's see-through on one side, but then solid on the other side. So the other option besides having an actual thick wall or a thick ground floor would be to try to do a double-sided material. That is an option. Now with that, let's go over, we'll take a look at our player here. If we look at our player, we have some new components. Now, we know the transform component has to do with all our transforms, the position, rotation, and scale. We have this mesh filter component. This is what controls what object. You notice the mesh here. So you can swap out the term mesh for object. The mesh is the 3D, and that is a sphere. So if we modeled, you know, some kind of cube character or some kind of cartoon character, and we imported it in here, we could actually replace this sphere by just dragging it into here. That would be one way. And the mesh renderer is what actually renders this object. So if I turn off the mesh renderer, this box here, you remember this is a Boolean variable, but this box has kind of two terms that we commonly use, right? We have it like disabled or enabled component, or set active true, set active false. Now, if we're just talking about the component, the mesh renderer here, you'll notice even though we can't see it, it still has a collider on, and it is still going to collide with things, even though you can't see the mesh. So we can turn off specific things. So we could see it, but we could turn off the collider, which means now it won't collide, but we can see it. Now we can also add a component here, right, where they're categorized in groups here, but we know we want to add some gravity and mass to our player. So we're going to type in rigid, and we'll just do a regular rigid body. That way we get the standard mass, and using gravity is true. And that way if we move our player up, if we were to play test this, the player is going to fall because of gravity. And it collides because the ground has a collider, the player has a collider, and same thing with the wall and our box. I'm gonna turn off play. So a couple things we might want to do for right now is we can turn on our collision detection to continuous, so it's always monitoring for a collision because this is our player. That's something that's pretty useful. And interpolate is a little bit more complicated, but if we hover our mouse over it, it gives us a quick explanation. It smooths out the effects of running physics at fixed frame rates. So this is going to smooth out our physics. So generally that'll help with smoothing. So we'll go ahead and turn that to interpolate. That's something we would probably go back and apply for our 2D game as well, because you would kind of set the same settings. Now, for some reason, we didn't want our player to rotate or anything like that. We could freeze the rotation. There's some constraints here, or if you have certain objects you want to freeze the position that they can't move with physics-wise, then we could freeze those. So the next thing that we want to cover is a little bit about the camera component real quick. So if we select our main camera here, it's nice you get this quick preview that is actually our game view. We can kind of zoom out a little bit, and you can see here's the camera. There's the forward facing, and then our X, red, and Y up and down. And here is where we can actually move our camera up. So I'm going to move it up, and I moved it up 3 on the Y because Y is up 3 units up. You'll notice that the default for the Z is -10. If we were to reset this, right, it's going to go to 0, and then all of a sudden you can see it's not where I want it. So even in the 2D game, it's always set to -10. We do that, we'll put it back to -10 for now, just so it's good. Like using the origin kind of as our starting point for placing objects. We have our camera there. Now, if we go to our camera component, which makes this specifically a camera game object, we have some things here. Now, currently our camera is set to have a skybox. So if we look around, it's kind of got this fake sky. You got like a gray ground. You got this kind of white fading to blue. That is actually the generic skybox, which we'll probably set something up later with a skybox that actually has a sky set out for us. But you can also change this to solid color. So if we wanted it in our game view, the player doesn't see the skybox, we could set that color to something. And voila, there you have it. I'm going to leave it skybox for right now, but that's just something to know. And there are kind of 5 other things that we want to take a look at. So our camera here, projection, is set to perspective. Now, there are really kind of 2 types of cameras that you're going to use and that Unity has, and that is either the perspective camera or the orthographic. A lot of 2D games are going to use orthographic. This basically means there's no perspective, right? And you'll notice some of the settings disappear. If we change it back to perspective, perspective has this field of view. This is what kind of makes it like our eyeballs. Our eyeballs have perspective, and the default field of view is 60, right? So what's the default field of view? 60. Now that we have some stuff in our scene, if we change it though, could make you queasy. And that is because if you change the field of view too high or too low, or change it drastically around, it can cause cyber sickness, as they call it. So we're going to leave that at 60. Now there's additional settings, but for just keeping it the basics, where field of view is only for perspective. If we go to orthographic, there's no field of view. So orthographic basically ignores the field of view. Now, the next 2 things that we have are similar but slightly different. So we have here culling mask. A culling mask, if we hover our mouse over it, this tells which layer the camera is going to render. So if we say render everything, it renders everything. So if we go in here, we have these layers. These are actually all layers. And you might be like going, okay, how do you know that? Well, if we go up to our inspector at the top here, you can see the main camera is set to the default layer, also index 0. And you have these default layers. We're going to go ahead and add a layer. So again, you can be selecting any object. So maybe you select player. We'll go to layer and then do add layer. And then on layer 6, we're going to call this the player layer. And all you have to do is type it in and you're good to go. We can go back to selecting our player. So we created the layer, but if we set the player to be on the player layer of the player. And I'm going to press, actually it's easier, press F or double click the player so you can zoom in. So if we go select our main camera, if we tell the culling mask to not render the player layer, you'll see in the game view, the player disappears. Now, at this point in time, you might be like, what would you use that for? It can be useful for a lot of different things. But for right now, just keeping it basic, culling mask means that you want to mask off maybe one layer. You want to have it to where the camera doesn't render certain things. You can use culling mask to do that. Now, the next one is a little bit different, but it has a similar word, right? We have occlusion culling. Now, this is, if I were to create, you don't need to do this, but I'm going to create a 3D object, and I'm going to do a capsule, and I'm going to stick it behind the wall here. Go back to my main camera, change it to perspective. And I'm going to push this capsule back behind the wall. I got to select my camera again. So now on our camera, based on our game view, occlusion culling, let's just hover our mouse over it for the quick definition. Right? Occlusion culling disables rendering of objects when they are not seen by the camera because they are obscured by other objects. So right now, our capsule collider is not being rendered because it is hidden behind another object, like a wall. So it's only going to render the capsule when we can see it. So why is this even important right now? Well, really, this will be important more later on, but this is a quick understanding of memory. It is going to save memory that it doesn't render everything just because. So if you have a massive scene, we don't want to render everything. We'll just tell it to render what is visible. And that's kind of the basics of the camera component. Light component is going to have similar things. We'll go more over the lights later because you got several light types, changing the colors and settings for lighting as well. A lot of these different processes can be found in the menus as well. So the player, we added a rigid body, but if we wanted to add physics to our block here, right, instead of coming over here and doing add component, you can also go up to the menu and do add component through here, and it's got the menus for the same things here that you can find. Just like game object, if we want to create a certain game object, we also have the game objects listed through the menu as well. The last thing we want to do is save. So if we select our sample scene here, we can do Control S on a PC. And to find the shortcuts, if you're on a Mac or Linux, you can go up to File, Save. In some versions, it actually said Save Scene, but it'll have the shortcut next to just Save. So we just do Save, Control S. Now, we did create materials and changed some of our project settings. So what we want to do is also, we want to go File, Save Project. So you want to make sure you save all of your project settings as well. So we save that, so we're good to go. And then if we wanted to back this up, we could save, close out of Unity, and zip up your project and put the date so that you have the first part saved and backed up, ready to go. Now on to the next part where we can cover more tips and tricks for getting started in 3D.